A mini golf course charges a flat rate of $50 to rent a room for a party and then charges $12 per child. Write an equation in slope-intercept form to represent the cost of a birthday party. Define your variables. Okay, so what we're trying to do here is we're attempting to find an equation and then define our variables to show the cost of a birthday party at some mini golf place over a certain number of people. So if we want to, we want to know if we have 10 people or, 100 people or however big the birthday party is, we want to know what's the cost up front. That way we can just pay it and be good to go. And if we have like a budget, right, we can kind of plan out and see, well, is this going to be too expensive if we have 10 people versus 5 people? So the first thing we need to do is we need to actually figure out what our equation has in it, right? If you remember any equation in slope-intercept form, right, if you have slope-intercept form where we have the actual slope in there, and then we have a y-intercept in the equation. Slope-intercept form is y equals mx plus b. And remember that m is our slope, right? The steepness of our line, and then b is our y-intercept. Okay, so this is slope-intercept form. And we're going to need to graph this using this form to show, if we plug in a certain value for x, what's our output going to be? Okay. First thing is, let's actually get the variables out of the way and let's define them. Let's do this piece first. Let's just get our variables done with. And we know that y is our output, right? So why don't we just do that first? Y is our output, or this is really the cost, right? The total cost of the party, right? So if we plug in something for x and we have a certain slope and a certain y-intercept, we're going to have a total cost of y. All of that is going to equal y. We know that x is the number of people, kids really, number of children. Okay, so if we plug in 3 for x, that's representing that we have 3 kids going to this party. M is our slope, right? M is equal to our slope. And then obviously B is our y-intercept. Okay. Now, normally you really don't have to define M and B because they're consistent no matter what the equation is, but I'm just putting them there for fun. The ones that you truly need to always make sure that you define are these guys. You've got y and x, because these are the ones that change all the time. These are actually the variables for any equation in y equals mx plus b form. Okay, so we've got these, and let's try to figure out what our equation would have to be. Okay, so we still have y, right? We still have y. That's always going to be our total cost, and that's going to change. So we don't really need to put a value for y. We just need to put a topic or make sure that we define y. M. We need M. Okay. Now let's think about this. We've got a flat rate of $50 to rent a room for the party, and then it's going to cost us $12 per child. It's going to $12 per child. And that's a key word there. If I say $12 per child, that means that can change, right? A flat rate doesn't change, right? A flat rate of $50, it's always going to be $50 no matter what you have at your party. If there's 100 kids or not, you're going to have this flat charge of $50. But this $12 per child, that's interesting. Our slope is going to be 12, and it's going to be $12 per child, right? We said this was number of children, so it's $12 per child. Plus, because we have our plus here, what's our y-intercept? Well, even if, let's consider that no kids come to the party. Let's say that we're, for whatever reason, the actual birthday boy gets sick and then none of his friends want to come, but we still already paid for the room, right? If this is 0, if x is equal to 0, we're still going to have to pay $50 to rent that room, right? So $12 per child plus the $50 that it's going to cost us to rent the room. So our equation here actually is y equals 12x plus 50. That's our equation right here. This is our equation. Okay. And again, you have 12 as your slope, so the rise and run, it's going to be 12 over 1 times whatever number of x's plus 50. Now, why don't we look at the graph of this, right? Why don't we just take a second and look at the graph here. Let's draw a graph. Okay, we can draw a graph. Let's do, why don't we make it, we can do green. We haven't done green in a little while. Draw this graph here. And something you might notice about how I'm drawing this graph is that the lines here only give me quadrant 1. I'm only looking at quadrant 1. And the reason for that is because I'm not going to pay any negative values for starters. So I'm not going to be traveling into the negative region of y because I'm always going to have to pay something, whether it's 0 or not. I'm going to have to pay 0 or higher. And I'm also not going to be dealing with a negative number of kids. You can't have less than 0 kids, right? You either have 0 or you have more. You can't have less. So there's no reason to waste my time trying to draw all the space. It's easier to look at here. Okay. Now the next thing is, right, we need to start our line somewhere, right? So I need to know where my line is starting. And the way to do that is to look at the 0, right, your y-intercept, because the starting point is x is equal to 0. That's the farthest left you can get, right? So we'll have x is equal to 0. And y, if we plug in 0, right, if x is equal to 0, so we have x and y. If we have x is equal to 0, 12 times 0 is 0 plus 50. Our y-intercept is going to be 50, right? So if we do, if we do 25, 25, 50, 75, 100, 25, 50, 75, 200, right? And you make this 25 and this 50, and then we have 100, and then 25, 75, 200, right? Let's say maybe 150. Our intercept is going to be right here, right? 0, 50. So if we have no kids at the party and we just rent the room, we'd have to pay $50. Okay. But let's say that we have 1 kid, right? What do we do then, right? If we have 1 kid, so it's just the birthday boy and, otherwise adults get in for free for some reason, right? We're going to have to plug in this number 1 for x. So we get 12 times 1, 12 plus 50, 12 plus 50, right, gives us 62. You add 12 in, right? So you're adding a child, you're adding 1 child, and then you're also adding in $12 because for every kid, right, it's $12. So it should go up by 12. So if we have 1 kid, we're going to go up by 12. If this is 75, right, 50 halfway in between. So we could say that, 10, this is a 15. So it's almost here. Let's say right about there, right? It's close to 75, but not crazy close, right? So we can plot that there. Let's say that we had 2. So we're going to add 1 more, right? We're going to add 1 more kid. That'll give us 2. Means we have to add in 12, right? 2 times 12 is 24. There's our 24, right? Plus 50. So that would give us our $74. And you add another 12 in. So then we have 2 right there. Say 2 kids, and then we have $74. So that's just about here, right? Actually, that's a little lower. That's a little lower. And let's make that other point lower too. Right, let's make that other point just a little bit lower. Not there. Let's make him right about here. Right about there. And then we'll make 0.2 directly on 75. That's better. And then 3. Let's do 3 kids. We'll add 1 more. Make this 3. We add 12 more. This will give us 86. Right? 7. So we put this up here. 86, that's 100. That's about right there. Okay. And you can see that this is going to keep going for a while, right? So we can actually just kind of draw our line in and predict for now, right? We'll start our line here. We'll draw it through and it'll continue forever in this pattern, right? Just like that. Okay. And so what you're seeing, right, is that you have this line that doesn't go past 0. So the domain of this doesn't go past 0. It's not in the negatives anywhere, but it can go in for infinity out towards, x is infinity and y equals infinity, depending on how many kids you want to bring, right? So this is our y equals 12x line plus 50. This is the number of kids, right? X is the number of children. And then y is the total cost, right? So this is the total cost of the party, and this is in dollars, right? And then your title would be the total cost of a party, total cost versus number of kids. Or children, right? You could say kids or children. Mm-hmm. And so let's say that we wanted, I think a typical birthday party for a younger kid might be like 10 or 9 kids, right? Let's say 9 kids. So what if we needed to find a value that wasn't in this graph, right? So right now we have up to 3. We might be able to go up to like 7 or 8, but what about like 9 kids? Something that isn't in our graph. It's too much to handle. We can just plug that value in, right? So if I want to know what the cost of 9 kids, so if x is equal to 9, right? What if x is equal to 9? You just plug it in, right? So you have y, right? Y of x, right, is equal to 12 times 9. You plug in 9, substitute it, plus 50, right? So we get y is equal to 12 times 9. Just in case, 12 times 9. 9 times 2 is 18. Carry my 1. 9 times 1 is 9, plus 1 is 10. So we get 108. So that is 108 plus 50, right? Which would give us $158 for a birthday party at this mini golf place.